Hello. What are you doing here? It's a baseball game. What's wrong with you people? I actually don't watch baseball, but apparently it should be like a city holiday or something today. Thank you for coming. Thanks for not skipping out for the baseball game. Actually, some people probably did skip out for the baseball game, so when you see them on Monday, make sure to shame them. But thank you all for being here. You're now my favorite people, so. You have an assignment due, though, on Monday. User sign-up, I believe, is due on Monday, if I'm remembering correctly. So you should definitely make sure you're keeping progress with that. Today, I think you actually, the studio today is not going to take up a huge amount of time, if you understand the concepts anyway. So you should have some time to work on user sign-up today if you need to get some of that work done. But let's continue our discussion from Monday on databases. Today is actually a very exciting day. On Monday, we talked about databases a lot, but we didn't actually have a database. It was a little frustrating because I wanted to run some code and try some stuff, and we just didn't, in class at least. In the prep work you did, I hope, run some code and try some stuff, but in class we didn't have any code. We wrote code, but we couldn't actually test it out. Today, we're actually going to set up a database for our application, for FlickList. And then next week, we're going to incorporate the database into our application. So all that Python stuff we've been working on, that's going to come back. We're going to start talking about that again on Monday. But today we're going to continue our discussion about databases. So let's begin. You had a little bit more SQL stuff. The prep work for this particular module was not nearly as involved as the prep work for Monday. So I hope you took advantage of that and went back and brushed up on some concepts from Monday if you had the time to do so. We didn't introduce a whole lot more in terms of SQL concepts, but we did introduce a few. So I'm interested in discussing a few of what I consider to be the highlights. What are some examples of constraints that you might expect to see in the database? There's a whole topic on this on the W3 Schools part of the prep work. What are some examples of constraints you might expect to see? Anybody? Not null is a very, very common one, so it can't be blank, has to have some kind of a value. What else? Unique? Okay, that's a good one. Pretty self-explanatory. What else do we got?
Check.
Check. What does check do?
It's almost like a if-then statement.
Yeah, so check is a lot more general. It lets us, it's like create your own constraint, right? So we get to make up what we want our constraint to be. Useful and very, useful in a lot of situations, just to make sure that you can think of it almost as an extra layer of validation. We talked about validation a couple weeks back. So writing a check constraint is just an extra layer of validation for our database. What else? Limit? What does limit do? Limit one. Oh, okay. Sure. I mean, is that an example of a constraint? I guess it kind of is in a broad sense of the term, but in the SQL sense of the term, constraints, this kind of leads to the second question. When do we use these constraints? You just mentioned deletion, but all of the other ones I would argue are used other places. Where are we using those constraints? The checks and the not nulls and that. When are we using those? When we create tables. They're part of our table definitions. They're part of our schema definitions. So other examples of constraints that we saw last Monday would be like primary keys. That's an example of a constraint. Foreign key is an example of a constraint. Very common examples of constraints that you might actually see out there. Used to define tables and properties of our tables. What is a view? Can somebody describe what a view is to me? What is a view? Don't overthink it. It's actually, the name kind of helps you. So I have a table that contains data. A view is literally a window into that table. Or actually, can a view span multiple tables? Is that okay? Yeah, it can. It can. So a view is just a way of reorganizing my data. Does a view actually store data? No. That's very important to realize. A view does not actually store data. So I got my tables, right? That's where all the data lives. The view is just sitting on top of it. It's just providing a little window into the tables. That's what a view is. It does not actually store any information, just provides a different perspective on existing information. Very, very, very useful tools. What might we use views for? Does anybody have an idea of what they're useful for? I don't know how much the prep work went into this, actually. Very useful. Restricting data access is a big one. I got a whole table full of information, and you can see some of those columns, but I don't want you to see all of them. Well, let's make a view. You can use the view all you want. You can't see the actual table. In fact, one of the big tenets of SQL security is to restrict access as much as you possibly can, and views are a great way of doing that. There are other reasons that views are useful, though. I can use views to store pre-computed values if I want to. So if you find yourself doing an addition on the same two columns over and over and over and over and over again, I can actually create a view that stores that addition and reference it instead of having to type out that expression over and over and over again. Great. What is SQL injection? I think we talked about this a little bit last time. What is SQL injection? Yeah, it deals with user input. So for flick list, for example, we saw this actually with HTML, not with SQL, right? How you were injecting buttons into our page. So the same thing, the same idea works with SQL. I would argue that it's more dangerous with SQL, a lot more dangerous with SQL than with HTML. Injecting HTML is definitely bad. We definitely don't want to allow that to happen. But if they inject SQL, they can access our data, which could potentially mean addresses, credit cards, phone numbers. And people don't like it when you expose that information. Just ask Panera. They had a very bad week. Or Breadco, I'm sorry, I forgot where I was. So how do we stop it? This is a really bad thing. We don't like SQL injection. How do we keep it from happening? We sanitize user input, we escape it, right? Just like we escape HTML stuff, just like we saw that during the validation class a week or two ago, we can do the same thing with SQL. The difference is, what are we escaping? We're not escaping tags anymore. We're not escaping HTML tags. We're escaping SQL code. So we're looking for things like parentheses, quotation marks, things like that. A little bit different stuff, but still the same idea. Or you can even look for particular keywords even. To protect against like select and from, and pay attention when those show up in user inputs. So SQL injection is definitely a big deal. The good news is that it's pretty widely known. I mean, people who are building websites are very conscious of it, and most web frameworks these days, like the ones that we're working with, come with some features to automatically help you out. They'll automatically escape stuff for you. They'll automatically try to sanitize stuff for you. That doesn't mean you should just trust that they'll be perfect, because they won't be. They won't catch everything. You should still try and do some of that work yourself. All right, what's a transaction? This was kind of towards the end of the prep work in the Khan Academy stuff. What's a transaction? What does a transaction contain? If I give you a transaction, you open it up, you peek inside, what do you see? What do you see in there?
A collection of queries.
Collection of queries, a collection of operations. Could be select queries or inserts or updates or deletes or creation of table. Any SQL query you can think of. A transaction is just a way of taking those and grouping them together into a single unit. Why? If the queries work, why do I need to group them together? Why not just execute them one after the other? Why do I need to... Don't want to mix them. So there's definitely a degree of isolation that transactions provide. That is important. There's another very important reason. Consider, let's say I'm creating a new database from scratch, and I write some create table statements, and I write a whole bunch of insertion statements to put data into my database. What happens then if I run that and I make a mistake, halfway through and the thing crashes? I'm now left in limbo where some of my stuff has worked and some of it hasn't, and I might not even know where it left off. I might not even be able to easily figure out how far it got down the process. So what a transaction does is it protects us from those situations. A transaction is basically saying this entire section of code is going to run as one unit, or none of it's going to happen. If a problem happens halfway in between, it'll actually go through and undo everything that it did prior to that point. So you know for a fact that that transaction is either going to run in its entirety or it's not going to run at all, which is a very useful thing to have, especially when you're doing the kinds of manipulation operations like updating, deleting, inserting stuff. It's nice to have that protection. So I guess I sort of answered the second part. When should we use transactions? In the Khan Academy stuff, they defined this concept called ACID principles. I don't think they actually ever told you what those were, though. They just dropped it. They were like, boom, ACID principles, and then they just went on to the next thing. I thought that was kind of rude of them, although some people in the comments were like, hey, what the heck are you talking about? So that was nice. ACID principles are useful for you to be aware of. This is a term that you hear all the time actually when talking about databases. So it's an acronym. It stands for 4 words that describe actually transactions, what transactions provide to us. The A stands for atomicity, atom like the very small, microscopic things, atomicity. What that means from a computer science perspective is what I was just describing. It means that either the entire unit runs or none of it does. All of it or nothing. The C stands for consistency. And the consistency in this case means that the transaction is going to take me from one valid state to another valid state. It's not going to leave me in some weird halfway situation where some of my data is good and some of it's bad. It's going to take me from one valid position to another valid position. It's going to be consistent. The I stands for isolation, which means that if I have 10 transactions running at once, they all behave as if they don't even know that the other guys exist. So they're all isolated from one another. That's what the I stands for. And finally, the D stands for durability, which means that once a transaction has completed, it is guaranteed to be part of the database from that point forward. And the way we enforce that is through log files. We keep a record of every transaction that gets run and every operation that's performed by that transaction in the database. So that if something goes wrong, like my server crashes or something like that, I can go back through the log and recreate those steps and make sure that that information is still up to date. So how does this help you in day-to-day usage? Maybe not so much. Knowing how to write transactions is useful. Knowing when to write transactions is useful. Understanding these concepts certainly is useful when it comes to understanding transactions, but I certainly wouldn't blame you if you already forgot 3 of the 4 things that I just said. So it is an important concept. It is one that you hear discussed a lot, so I wanted to take some time and go through it since the prep work kind of left you hanging on that one. What questions do you have? The prep work was a lot lighter this time than last time. There wasn't as much stuff to pull out, but I didn't do all of it. Is there anything from the prep work you were hoping I would talk about that I didn't quite get to today? It went through creating tables. We actually saw creating tables last time, so I didn't feel like I needed to rehash that a whole lot this time around. It went through creating databases, and then the opposite of that, dropping things, which is useful but dangerous as well. Are there any questions about any of the topics before we hop into the walkthrough? All right, so this is the fun part. I hope you all installed MAMP. The instructions were in the prep work. If you didn't, you're not going to be able to do the walkthrough with me today, but you should definitely 100% install MAMP before you leave here. Get all that set up. If you had problems with installation, flag me down or flag down your TF. I'd be happy to make sure you get all that stuff installed successfully before you leave here today. That should be one of your main goals. Hopefully you got it installed. If so, we're going to start doing some work within MAMP. The prep work basically had you install it and then stop. Didn't really have you do much beyond that. So I'm going to switch over to the walkthrough. What we're going to do is we're going to load up a database that we want to use with our application. This is a pre-formed set of data so that we don't have to type in all that stuff. We just have a data set that's ready to go, ready for us to be used. The first thing that we need to do is set up a user account. And setting up user accounts is very important. You'll notice here actually in the walkthrough it says that Does it say that? Oh, okay. It does say, I thought it said it. Oh yeah, here it is. A good pattern to follow is that you should have a different user for each application. This is so that if something happens to the database, it blows up, somebody makes a mistake, some information gets removed or whatever, and you think it shouldn't have been, that you have a way of tracing back to where the problem was. You don't want everybody to just log in under the same user, because then when problems happen, you don't have a way of tracking them down. So a good thing to do is make one user per application, so you can see you can monitor that database access. So that's what we're going to do first. We're going to start up MAMP and create a user. So go ahead and start up MAMP if you haven't done so already. I actually use MAMP at work. I already have MAMP on my computer. It's a very useful tool. I use it all the time for classes and stuff on campus. So I already had it. Mine starts up automatically when I open it, but if it doesn't start up automatically, click the button, make it start up, and hopefully you see the boxes are filled in. That means that everything is okay. You can open a browser and type in the address if you want to, or you can just click this Open Start Page button that should fire it up in a browser for you, take you to a page that looks something like this. My version of MAMP is probably a little bit older than yours, so it's possible that yours looks a little bit different than mine. But we need to get to PHP MyAdmin. So there's a link down here, or I think if you click the menu button up top and then go to Tools, there's a link to PHP MyAdmin. However you want to get there. Go on to PHP MyAdmin. It might make you log in. I think I have my password saved, so it doesn't actually ask me to log in. But if it does ask you to log in when you get to this page, it should tell you what the default is on the, I thought it did. Root and root, yeah, if it asks you to log in. Mine actually did not, but do what you need to do. So I'm going to pause here. All I've done so far is start up MAMP and make it PHP MyAdmin. That's all I've done. I haven't done anything else. Actually, if you look, mine's going to look a little bit different than yours, because this stuff over here, that's stuff that I use for work. You're not going to have that stuff. Yours might have a couple of these, but it won't have all of them, because that's stuff that I made for classes and stuff over on campus. What we want to do, these are actually databases. These are different databases. What we want to do, part of the main goal of this walkthrough, is to get our database to show up over here for the movie application that we're working on. So that's what we're going to do, starting with creating a new user. So up at the top, you see a user accounts button. Go ahead and hit that. And here are the users that you can see already exist. Your list might look a little bit different than mine. That's okay. I'm not worried about it. We need to make a new user for our flick list application. So down here, you'll see there's a button that says Add User Account. That's what we're looking for. Go ahead and hit that. Pull up a window. Yeah. I clicked User Accounts, and then there was a button that said Add User Account. Do I need to zoom in a little bit? Can I scooch this over? Oh, there we go. That's useful. Okay. So I just click this Add User Account down here, and it pops up this window, and now we have to make some stuff up. I'm going to try and stick pretty close to the script. I actually would encourage you to stick close to the script as well, because then if you forget your password, you can just ask the guy sitting next to you and they'll have the same password as you. I know it sounds ridiculous, but actually it will help so that you don't forget that critical information. If you really want to do your own thing, I'm not going to stop you, but when you forget your password, then it's all on you at that point. So I'm going to try and follow this. There's actually a screenshot down here that kind of shows you what it should look like. They're using movie-buff as the name. So type that in, movie-buff. The host name is going to be local. So select local from the drop-down. It should fill in localhost here. Now we get to make up a password. Just pick something easy. I'm going to pick launch code, all lowercase, right? Easy to remember. Launch code, all lowercase, which is a weak password, by the way. Oh well. If somebody wants to steal my movie data, then they can have it. And we have to type it in twice. make sure to type it in twice. The last thing that we need to do, I believe, is I want to make sure I get this right. So I'm going to just double check. Yeah, create database with same name and grant all privileges. So we're going to click on this checkbox down here that says create database with same name and grant all privileges. So just to recap, this is important. I typed in the name movie buff. I selected local here. I typed in the password, which is launch code, and then I typed it in again. And then I checked this box that says create database with same name and grant all privileges. Are there any questions? Because if we get this stuff wrong, then we're about to click a button that makes it very hard to change this stuff. So you have questions, now's a good time to ask. We all good? We're all on the same page? Okay, we're gonna go ahead and click the go button down here at the bottom. We're gonna skip all this stuff, don't worry about it. Just go right on past. Click the go button down at the very bottom of the page, and hopefully it tells you that you've added a new user successfully. If you got an error, then that's definitely something you should talk to your TF about, or myself. Flag me down. I'd be happy to figure out what happened if you got a problem here. But hopefully it says you've added a new user. That's what we would like to see. This is the user we're going to use for our application. So that's step one of the walkthrough. Step two of the walkthrough is to get some data in here. We actually want to get some information. You'll notice that over here on the left, I now have a new entry on my list called movie buff. That's because we checked that checkbox that said to create a new database for us with the same name. So here's our database, and I can click on it and see that it's actually empty. There's nothing in it. No tables found in database. There's no information. So there's a couple ways we could fix that, right? We know how to create tables. We can write those statements. We know how to insert new information. We know how to write those statements. It takes a long time. It takes a really long time, especially if we want any significant amount of information. So what we're going to do instead is use some information that's been provided to us. So go back to the walkthrough here. You'll see a section that says import tables from SQL. We provide you with a SQL file. We need to download this guy. Uh-oh, I'm not on the internet. My fault. Let's try that again. There we go, that's better. In a second, we're going to load this up, but before we do that, I actually want to just take a peek and see what's in this file. Let's peek under the hood. You don't have to do this part if you don't want to, but I'm curious, so I'm going to open it up and see what it says. So here is what's inside of this file, and right up at the top you see, okay, this was made last year, around May. You see some stuff that we haven't really seen before, set SQL mode, set time zone, and then all this fun stuff here. I'll be honest with you, I don't know what that stuff's doing. I have no idea. But I bet down here, all right, perfect. This looks familiar. Create table. There's some stuff in here that we haven't talked about, if not exists, but that's pretty self-explanatory, right? If this table doesn't already exist, then I want you to create it, and you can see the columns. This is actually one of the ones that we talked about last time. On Monday, we wrote a very, very, very similar statement to this. There are some differences here. There's some extra stuff down at the end. And then it inserts a whole bunch of data. There's that guy that we talked about last time, right? Inserts a whole bunch of data. Well, a whole bunch, 9 rows. It inserts some information for us to play around with. It does the same thing for movies. More movies this time, which is good, and then inserts viewers. That's going to be our users, and then viewings, so counting how many times they actually watch the movies. So we're just creating some sample tables, and then it sets the primary keys, sets foreign keys, does some other stuff down here. Let me give you a little background on this file. This was not written by a human being. This file was not written by a person. Somebody got the database set up in a way that they liked and then told the computer, hey, write SQL queries that will replicate this database for me so that I can give it to somebody else and they can have a copy. This is computer-generated code. So on the one hand, Sweet, the computer writes SQL code for us. On the other hand, they write weird SQL code that I don't know what it means. So that's kind of the downside of using computers to write code for you, is that they're going to do stuff probably a different way than what you would have done if you had done it yourself. Another example you see of the computer doing things a little bit odd is that, they didn't add the primary keys right away for whatever reason. They created the tables first and then added the primary keys later. All right, potato, potato, right? But that's not how I would have done it. It's probably not how you would have done it. Or maybe it is, I don't know. I don't want to make assumptions, but this is code that, I'm almost positive this is code that was generated by the computer. A human being did not write this, at least not directly. In fact, this up here at the top confirms it. SQL dump confirms my suspicions. Anyhow, I just wanted to take a peek and show you guys what was under the hood here. What we're going to do next is run this code in on our server so that we actually get this data into our database. So I'm going to go back to the walkthrough. There's a couple ways we could do this, but the quote unquote officially sanctioned way to do this is to open up PHP MyAdmin. Make sure you have this selected, right? It says double click. You don't have to double click. You can just single click, I think, and that's okay. And then we need to do an import. So mine's under this More tab. It depends on how much room you got on your screen. I was zoomed in, so I had to go to More. But find this import button. Click on that. And then it wants to know wherever you put that file. So hit the Choose File button, and wherever you happen to download it, find that file. What was it called? It was called moviebuff.sql. So mine's just in my downloads folder. Moviebuff.sql. Wherever you put it, stick it on the desktop, whatever is easiest for you. Just find out where you download that file, select it. Let me just double check and make sure we don't need any of these other options real quick. Yeah, leave the defaults. Yep. That's what I thought. Leave the defaults as they are. And then hit the go button down here at the bottom. And cross your fingers. If this doesn't work, I have a backup plan, but it should work. Yeah. Successfully finished. Hopefully this is what you see. If you don't see a success message, this is another case where you should definitely talk to your TF or talk to me about this before you leave here today so that we can get those kinds of problems resolved. There is another option. There's actually 2 or 3 other ways I can think of doing this. So if you have a problem with this, don't freak out. I got some tools in my pocket that I can use to help us out with the situation. But hopefully, I hope that this worked. And you can actually see over here that, hey, we have tables now. Those tables that we saw in the code actually exist. And you can play around with those a little bit in PHP MyAdmin. So for example, if I go to the directors table, actually you can just click on the directors table and see, oh hey, this is the actual data that's in the table. This is the stuff. There's the directors. Same thing for all the other tables. So it's all here, I hope. Now, one thing I want to point out to you, I run into this on campus as well when I work with databases on campus. My students see buttons over here like edit and delete, and those buttons look very tempting, right? In fact, you can click these buttons and change these values if you want to. It does exactly as advertised. But we want to learn how to write SQL code because you're not always going to have a box that you can use to type stuff into. And actually, I would make the claim that using the boxes and clicking with your mouse is going to take longer. It's going to take more of your time to do it this way. So, if you use this to change a few things, I'm not going to, call you out on it or anything, but we do really want to encourage you to write the code. It's going to be faster. You're going to understand more than just clicking the boxes to manipulate data in your database. And the other reason to consider why code is important to learn, on the Python side of things, there's definitely no boxes. They don't exist. We have to write the code. We have to write the queries to make our stuff work. So write the code. That's the moral of that story. Let me show you how to do that. Make sure you've got the movie buff database selected. Make sure you've got this selected. Up at the top, there's a button that says SQL. And if you click that, it comes up with the empty box. And inside of this box, you can write whatever SQL query you want. In fact, I'm going to do something that's been bugging me for the last 3 days. We wrote those queries at the end of class on Monday, and we never got a chance to run them. Well, hey, guess what? I can run them now. And I can check them to make sure that they actually work. I'm not going to run all of them, but I at least want to run a few of them. I saved them. They're right here. These are the queries from Studio on Monday. Here they are. So let's just start with a very simple one. You can either copy paste it or type it in, whichever you prefer. But you know, if I pull this in, I know it's a little hard for you all to see maybe on the projector. It actually highlighted this in purple for me, so it recognizes that word, just like we see in code, Visual Studio Code. So it recognizes those words. And then, you know, type in the query and then come down here and hit go. And hopefully everything works. Hey, look, there it is. The titles of all the movies in my database. That's nice. There it is. Let's try one with a join in it, because we had a few that used joins down here. We wanted to, so this is interesting. This one is a query that we wrote. Let's work backwards this time, though. Go up to show query box. So I'll delete all that stuff and paste this one in. We wrote this query based on a question that was presented to us. I don't remember what that question is. Let's see if we can work backwards. I have this query. What is this query doing for us? Can somebody explain to me without looking it up? Just based on the code that you see here? What is this query going to tell me? The country of the director of Amelie. And you can see that, so in the select I see country. Right? Down here in the where clause, I see Amelie, and the join is just because those two pieces of information live in different tables. Amelie lives in the movies table, country lives in the directors table. Let's try it out and see what happens. Whoops, France, there it is, boom. There it is. Hey, that query worked. That query worked. So you're welcome to try out the other queries from last Monday as well. I believe for Studio today, you're going to be writing even more queries. You're going to get a lot more practice writing queries today. And so yeah, here's a whole bunch more. 10 more, actually 13 down here. 13 more queries to take a look at. We've got more tables this time. Last time we just had 2, movies and directors. Now we've got viewers and viewed as well. So we've got some information tracking when people have watched stuff, who's watched what movies at what point in time. That should allow us to do some more complex things, some more interesting SQL queries, which is going to be your task for Studio today. What questions do you have? What questions can I answer about this process? Anybody got anything? I know it's kind of a short review session today, but you use this time wisely, right? Please work on the Studio. Please submit user sign up, and please make sure that you've got all this stuff installed and ready to go on your computer before you leave here today. Question?
I noticed in your queries the tables are capitalized, but in your data it's actually lowercase.
Yeah.
I guess it's not case sensitive.
It's not case sensitive. SQL is famously not case sensitive. Most languages are. Python certainly is. For most things, SQL is very famously not case sensitive.
Even in the strings?
So I think if for matching movies, like that's a good question. Let's try that real quick. Let me go back to my original query. If I switch this to be like a lowercase a, I think at that point it probably would care. Nope, it didn't. It doesn't care. At least not for this particular result. Did not care. So, and actually, when I say that SQL is not case sensitive, you actually can adjust how case sensitive it is. There are options in the server that you can set to make it more or less case sensitive. Clearly, the default options are not very case sensitive at all. Hardly anything is case sensitive that we've tried out so far. If that bothers you, I certainly understand. Feel free. In fact, I was curious about that myself, whether it would actually let me go through with that or not. I was a little bit surprised when it did, not super surprised when it did. If it bothers you, then, you know, match the case for things like tables and columns. It's totally okay. I do like to capitalize clauses, though. I really, whoops. Well, here's a nice feature since I accidentally clicked on that thing. It helps you out. If you write a query and you want to know more information about particular words, it will, well, it did it for that one. It's not doing it for any of the other ones. I don't know why. Thanks a lot. Yeah, you just get the one. I don't know why I picked that one out in particular, but that was kind of cool. Any other questions before we break up? Yeah. The PHP MyAdmin software? Okay, yeah, so that's a great question. He just was asking a little bit more about the tool, where it came from, what it's actually used for. It's definitely for developers. I don't want my users to see this. But it's very useful for me. It gives me, this is a sandbox that we're creating essentially, of a zone where we can manage our data, track our data without worrying too much about destroying stuff. If we destroy stuff, we have a reset point we can go back to. So this is just sort of a playground for us to create tables. I use this to test out different structures for my data. If I'm unsure if I should have, you know, tables X, Y, and Z, or tables A, B, and C, I'll build them both ways, try out a few queries, see which one behaves the way that I want it to, and then use that in my final product. Should not be used as your primary access point to a database, purely for development purposes. Your primary access to your database is going to be through the application, the flick list, the Python, and that's what we're going to see next week. So yes, this is very much an application for developers. This has been around forever, by the way, PHP MyAdmin. I mean, I remember using this when I was in college back in the early, mid-2000s, and it's been around even longer than that. If I had to guess, I'd say late 90s, early 2000s when it first came on the scene. And if you haven't noticed, it really hasn't changed much in how it looks since then. I'm not a big fan of the style, but they basically don't care. It works, and it does a good job. That's why people use it a lot. It's so convenient. Think about what you would have to do if a tool like this didn't exist. You'd have to write queries for everything, which would get very tedious after a while, and you wouldn't have an easy way of checking to see if stuff worked or not as well. So it really simplifies the whole process. There are other tools like this as well. This is not the only one out there, but it's a very common one. It's a very popular one. What other questions do you have? Is there a question over here in the back? No. So if you're setting up on a different computer, you would have to go through this whole process all over again, unless you treat your computer like a server and allowed outside people to log in to your machine, in which case you wouldn't have to install anything. You could just log in with the same credentials. I don't recommend that because you're also opening your computer up to all kinds of other stuff by doing it that way. And your computer is probably not set up to handle that kind of stuff. So if you want to use a different computer, if you have a computer at home, I would recommend just going through the installation instructions all over again from scratch on that computer. It doesn't take that long. It takes 15, 20 minutes, hopefully, if nothing breaks. So. Well, so if you install it on a different machine, you've then got two different copies of the database, and changing one database is not going to change the other. They're completely separate. No, they're totally separate. In effect, your computer is acting as a server when you install and run this software. So everybody's computer is acting as a server, but the only person who can see that server is you on your computer. That's more for security and protection purposes, makes it convenient. If you get a job with an employer, they're going to have a server, right? They're going to have a server somewhere that everybody can access, or multiple servers that everybody can access. So you wouldn't necessarily have to install this yourself. You wouldn't have to go through this process. You can just access their stuff. But for our purposes, this is the easiest way to go about it. What other questions were there? Yeah.
Sorry, this is going back a little while because I couldn't find it earlier. In the W3 school, under the SQL or SQL primary key, it says to allow naming of the primary key constraint and defining a primary key constraint in multiple columns.
Sure.
I guess I'm confused. Can't there really only be one primary key?
There can only be one primary key, yes, but a primary key can span multiple columns. So one column may not be enough to uniquely identify each individual row, but maybe two columns would be enough. Maybe the combination of two columns would be enough to uniquely identify each row, or three columns, or however. There's no limit, really. That situation does arise from time to time. It's called a composite key, a composite primary key. I think one of these might have an example of that. I don't remember actually if it does or not. What's the primary key of this table? That's what I wanted to know. Does it say? I guess I could look at the code and see what the primary key of the viewings table was. Does it say down here? Where's the primary key? Yeah. Well, yes. I believe this is saying that the primary key for the viewings table is the combination of the viewer ID and the movie ID. I believe I'm interpreting that correctly. Maybe
See that stuff under the structure tab?
under the structure tab, is that what I was looking for? Oh, thank you. That is exactly what. No, I was wrong. My bad. These are foreign keys. That's what that was referring to, but still just one primary key, the viewing key. Yeah, so no examples of a composite in this database, I don't think, but it is not uncommon. It's more common than you might think to have a primary key that spans multiple columns, called a composite key. Thank you. What other questions do you have? Any other questions? All right, cool. Let's go ahead and split up. Let's write some SQL and get user signup finished and hopefully get this stuff installed and up and running on your computer. Let me know if you need anything.